judge.
I've never been a judge before.
Oh, I don't know if I have either. Okay, so now
Okay.
I think we've made it through, I think, kindergarten through first grade, um, right?
Yeah. We jumped into second grade a little bit.
I think we're doing pretty good. Um, there we go. Kelsey's saying, "Wow, that's beautiful. I'm amazed. You guys are fantastic." So we are.
Uh,
That's good.
well, thank you.
Um, so Jaden, do we want? I think I remember in like first and second grade, maybe not. This whole idea of maybe it wasn't. No, maybe it's later. Should we? Let's go on to multiplication now.
Okay, sounds good. New page.
New page.
Wonderful. So multiplication, we can represent that with a little x for times. We can represent that with a dot. We can represent that with parentheses. We could represent that with, I guess, if it's just a number times a letter, right? They're just right next to each other. So there's a whole bunch of different ways we can
You
represent
can do a
multiplication
star for on the computer if you can't
on the,
figure out.
yeah, on the computer. Nice. Yeah. Um, all these different ways of multiplication, uh, you're usually taught with the little x, right, in third grade or whenever you start learning about it. Uh, it's usually an x, then you start getting to higher math and you kind of just never use the x again, and you use the dot, parentheses, this 3n where it's just a number right by a variable. So that's just kind of the notation. And Kip, you want to explain to us what multiplication is?
Oh boy, here we go. Okay, so multiplication. If you, let's think here. So Jaden, I'm gonna go back to the circles because you chose circles, which are boring, but oh well. So in
They're
that
just
previous
fast and
example,
easy, you
okay,
know?
I had 3 circles and Jaden only had 2, but we don't care about Jaden anymore. We're only gonna care about me. Um, so if you have 3 circles, and then Jaden, or you know what? I'm gonna change this up a little bit. There is a box of 3 circles, okay? And there's a
Ooh,
whole bunch of these boxes of 3 circles. All right?
okay. And are all these yours?
No, not mine yet. I'm at the store,
Oh,
okay?
okay,
I'm showing up at
gotcha.
the store, and I'm like, hey, I want to buy some boxes of circles, all right?
Yeah,
So,
because those are the best toys.
yeah, I love circles. I always go to the store, I'm like, dude, I want more circles.
Same.
But if I go, look, this is me, dude. I'm walking to the store, and I go and take this one box, okay? Now I have 3 circles, right?
Dude, that's a really cool hand.
Thanks, dude. I'm Spider-Man. It's my web.
Oh, gotcha. Okay, so you
Um,
take that one box and you got 3 circles. Okay.
okay. Now, if I go grab another box using my spider webs, now how many circles do I have, Jaden?
Well, now you would have one more box and 3 more circles.
And how many circles do I have altogether now?
You have 6 because 3 plus 3 equals 6.
Okay. So, then I go get this third box, and how many circles am I going to have?
You will have 9.
I will have 9 circles. Yay! I have way more
Yay.
circles than Jaden because I stole 2 of his, and then I got 9 more, so I'm up to 11 circles. I'm not sure what
You,
Jaden's at.
Yeah, you jerk. You took two of mine.
Dude, you told me to. I didn't do it willingly, is all I'm gonna say.
Yeah,
All
yeah.
right.
I made you the bad guy.
Yeah, you framed me, man. You framed me.
Yeah.
Okay. So back to this. Now, if I have 9 circles, you said that was 3 plus 3 plus 3, right? Here, I'll write those under each one of these groups of circles. Um,
Right.
so 3 plus 3 plus 3. Or we could write 3 times 3. These both equal 9. We'll use that for now. So how multiplication works is you group some quantity, some object, right, into a group, and then
Okay.
you know, you add all of those groups together, how many groups you have, right? So it's kind of like a shorthand way of writing addition over and over, right? It's kind of like a way of,
Right.
instead of having to write 3 plus 3 plus 3, you just write 3 times 4. If or 3 times 3, not 3 times 4. That's where my mind's going. If we had 4 boxes, then it would be 3 times 4, right? It's a
Right.
shorthand way of writing a whole bunch of addition together that's the same.
Okay.
Is that, and do you feel like that's a good explanation, or do you want to? I mean, you're more than
Yeah,
welcome to
I
explain.
think that is good. Uh, I probably would have done something similar. Maybe I would have used triangles instead of boxes, but whatever.
Dude, you can't put circles in a triangle. That's not very efficient.
What do you mean, dude?
I'm pretty sure if we wanted to calculate it, I would win, and you could pack more circles into a box than you could into a triangle.
Well, does yours look like a pepperoni pizza?
Nope. But mine looks like a Lego brick, sort of.
Yeah, it looks like the bottom of one of those big Legos.
Yeah, see? And people like Legos more than they like pizza, maybe? I don't know. Let us know in the comments. Legos or pizza?
Let us, yeah. Are you an adult or are you a child?
I don't think pepperoni pizza defines adulthood.
Yeah, I was talking about Legos for adults,
Oh.
pepperoni pizza for child. Okay, so what follows after multiplication?
Well, I think we're gonna say it's the inverse of multiplication.
Okay, and that is division, right?
Right.
We can represent it by this sign. You might see it with just a slash. You might see it with a horizontal bar with some number on top, some number on bottom. Uh, what other ways can we see multiplication or division?
Um,
Oh, the long division
yeah,
way where you have a number and like that.
I think that's
Yeah, I think.
about it.
Okay. So when we're first taught, we see this symbol, right?
Yeah, which in my
Um,
personal opinion is like the worst symbol. I'm not sure why we're taught with that symbol.
yeah. In higher math, we generally see numbers like this in fraction form, which is just division. Or if you're, I don't know, programming or something, you might use a slash. And then if you're fancy, you'll do some long division when you're actually trying to do it by hand. But most people just use a calculator nowadays, right?
Right.
Uh, so, what does division mean?
Well, to me,
If we
Jaden, yo,
are,
you go,
yeah,
you got this.
okay. So I'm thinking Kip works in this factory now. He has all these balls. That was a whole bunch of balls.
Oh, they're not circles anymore. They're full on balls.
Yeah, or circles. I don't know. How many circles or balls do you want?
Dude, I don't know. Should we stay with the groups of three? So like 9? Let's do 9.
Sure, there's 9, right? Yeah. Okay. So Kip, you want to draw yourself at this factory?
Yeah, dude, look at me. I'm over here. I got my construction hat on because
Okay.
this is a dangerous factory to be working at.
Yep.
Oh, dude, I got a big helmet.
And Jaden over here, green big Jaden, he is a supervisor, and he's like, "Hey, Kip, I want 3 balls per box because we're getting ready for Christmas. We got to get these shipments filled out, and we got to ship these balls to kids, or balls, circles. I don't know what we're using, but we have to ship these to the kids." Okay. So Kip, he's like, "Okay, I got to put 3 balls per box." Okay.
Okay.
So he did his job very well. He got the 3 boxes because there were 9 balls, 3 balls in each. So written out, this would have been 9 divided by some number. We didn't really know that at the beginning. Equals. Just kidding. I did know that.
Yeah, you did.
3, and it equals some number that we don't know. Sorry.
You're okay.
But now we do know it because Kip did his job very good. Good job, Kip. And how many boxes did we end up with?
We ended up with 3 boxes, so that, hey. So now I can go to the store and go buy my 3 boxes back with the money I
You can go. You can go get some more balls or circles. Okay. Uh, did that explain it well enough for your liking, Kip, or do you
I
want to add anything?
I think so. I think I like to add one thing, which is
Yeah.
when talking about division, it's how many times it's the inverse of multiplication, right? And
Yeah.
so I think maybe on the next slide, now that we've got multiplication, division, addition, and subtraction, it might be a good time to kind of start talking about what an inverse of of an operator is and why those are important. But this might be a good
Okay.
segue into that, is that when you take or when you're dividing, you're trying to figure out how many times something goes into something else, right? So in this case, it's like how many groups of 3 go into 9? Well, it's 3, right? And
Yeah.
so it's trying to reconstruct, essentially, in my brain. It's like taking apart the multiplication equation
Uh-huh.
where we know one side of the multiplication. We know how many things fit into each box, but we don't know how many boxes. And so we're trying to kind of reconstruct that multiplication question, that equation, but like in reverse. And so that's why I
Right.
think, it is interesting to me that things like division can be so much harder for someone than multiplication, right? It's a lot easier to represent multiplication, I feel like, than it is to represent division. I feel like it's harder, right? When you can look at a box and go, well, there's 3 in that box, and then if I have 2 boxes, then I have 6. I have 3 boxes, I have 9. But I feel like it's harder to
Yeah.
visualize. Well, if I have 9, how do I break them into each box? But you can still do the inverse, right? Which, Jaden, what you did here was you did 3, then 3, then 3. So just like multiplication, we could do 9,
Yep.
and we could do -3, -3, -3 until we got to 0, right?
Right.
So it's the same thing as multiplication, where multiplication is addition, and then division is subtraction, trying to get as close to zero